You would have to remember those particles or subparticles, especially when you balance the nuclear reactions. Say we have 14C6 and also 14N7. Which particle would be released in the transmutation or changing of the C nuclear into N nuclear? To be able to do this, we have to balance both the numbers, so the mass numbers and also the atomic numbers. In this case, we can tell that the upper part will be 0 because we have 14 at the left side and 14 at the right side, while for the bottom part, it will be -1 for the product side because, and then we have 6 at both sides. And 0 minus 1 is actually a beta particle. So we can write this down. It's actually a beta particle. Now, when we release some particles like this, we call the process is a decay process or an emission. So based on this, the types of reactions you can recognize later on: the alpha decay when it releases alpha particle, positron emission or positron decay where it releases positron particle. It could also release gamma, so gamma decay. It could also, of course, release electron or electron decay or electron emission. When you see these words, decay or emission, that means the particle will be positioned at the product side. On the other hand, we can also have the term of capture. Now, capture means that it receives those particles. So say if we have electron capture, we can see the example of the reaction as such. We have radioactive aluminum, so Al, plus electron 0 minus 1, forming, in this case, 2612 Mg. This is an example of electron capture reaction. So you can see in here, the same balancing principle still applies. The upper part has to be 26 plus 0, so 26. On the left side, it is 26, so on the right side it also has to be 26. While the bottom part, 12 at the left side and also 12 at the right side. So if you see this word capture, that means the particle will be at the reactant side. In opposite with the decay and emission, where the particle will be at the product side. So you have to be able to recognize these reactions and, of course, balance the reaction. The principle of balancing the reaction is both sides have to have the same number of mass and also same number of the atomic number. So both has to be the same for it to be able to be balanced. The nuclear reactions actually occur because we have unstable isotope. So the isotopes that we know in nature, some of them are unstable and therefore they can change into other type of atoms. And in this case, the changing of the nucleus to another can produce a lot of energy and can produce an activity that we call the radioactivity. Therefore, this chapter is also closely related with radioactive isotopes. In general, there are 3 types of nuclear reactions based on how the nucleus changing into one another. The first one we call the transmutation reaction. In this case, it is simply a change of one nucleus into another. For instance, we have the previous example where we have 14,6 carbon becoming 14,7 nitrogen and in this case, releasing or emitting a beta negative or electron particle. So this is what we call transmutation. Just a simple change between one nucleus into another, because 14,6C is not the stable kind. Then it will become more stable when it reaches the nitrogen form. As you can see in the periodic table, carbon, the most stable one, is actually around 12-ish for the isotopes. And 14,6,1 is the unstable isotopes, and therefore it is radioactive. Second reaction is the fission reaction. Fission reaction normally happens when we have large nucleus. Large nucleus that would then form smaller nuclei. So sort of decomposition of this particular nucleus. The example is for 235 uranium 92. And this is the classic particular element that we use in the nuclear reactor. In this case, the uranium can be divided or decomposed into two different nucleus. For instance, barium and krypton, while producing a large amount of energy. And the third one would be the fusion reaction, where actually this is the opposite of the second one, where we have smaller nuclei combining with one another to form a larger nucleus. The fusion reaction we often correlate with the process that occurs at the surface of the sun, where we have smaller nucleus of hydrogen, for instance, forming a large nucleus.